Hi, I am Geetha from Assistant Professor of Computer Science in the A.D.M. College for Women, NAGAPATTINam. In this session, we will see about machine learning. Machine learning is a branch of artificial intelligence that focuses on developing models and algorithms that let computers learn from data without being explicitly programmed for every task. ML teaches systems to think and understand like humans by learning from the data. Why do we need machine learning? Traditional programming requires exact instruction and doesn't handle complex tasks like understanding images or language as well as. It can't efficiently process large amount of data. Machine learning solves this problem by learning from examples and making prediction without fixed rules. That is solving a complex business problem. It can be as traditional programming struggles with the task like language understanding and medical diagnosis. The ML learns from data and predicts outcomes easily. For example, image and speech recognition in healthcare and language translation and sentiment analysis. And for another one, handling large volume of data. The internet generates huge amount of data every day. Machine learning process and analyze this data quickly by providing valuable insight and real-time predictions. For example, fraud detection in financial transactions, personalized feed recommendation on Facebook and Instagram from millions of instructions. Automatic repetitive task. ML automates time-consuming repetitive tasks with high accuracy, hence reducing manual work and errors. For example, Gmail filtering spam mails automatically, a chatbot handling over tracking and password reset, automating large-scale invoice analysis for key insights. Another one, personalized user experience. ML enhances user experience by tailoring a recommendation to individual preference. It analyzes user behavior to deliver highly relevant content. Example, Netflix suggestion movies and TV shows based on our viewing history. E-commerce sites recommending products we are likely to buy. Another one is self-improvement in performance. ML models evolve and improve with more data, helps in making them smarter over time. They adapt to user behavior and increase their performance. For example, voice assistants like Siri and Alexa learning our preference and accent. Search engines refining result based on user interaction. Self-driving cars improving decision using millions of miles of driving data. How does machine learn? Machine learns by identifying patterns in data and improving its ability to perform specified tasks without being explicitly programmed for every scenario. This learning process helps machines to make accurate prediction or a decision based on the information they receive. Unlike traditional programming, where instructions are fixed, ML allows models to adapt and improve through experience. Learning process models. It learns through the data input. Data input means machine needs data like text, image or number to analyze. Good quality and enough quantity of data are important for effective learning. And algorithm. Algorithm or mathematical methods that help the machine find patterns in data. Different algorithms help a different task such as classification or regression. Model training. During training, the machine adjusts its internal settings to better predict outcomes. It learns by reducing the difference between its prediction and actual results. Learning process works. Feedback loop. Machine compares its predictions with the true outcomes and use this feedback to correct errors. Techniques like gradient descent, it helps to update and improve. Another one is experience and iteration. Machine repeats training many times with data helps in refining its prediction with each pass. More data and iteration improve its accuracy. Evaluation and generalization. Model is tested on unseen data to ensure it performs well on a real world task. What was the importance of data in machine learning? Data is the foundation of machine learning. Without quality data, ML models cannot learn or perform or make more accurate predictions. Data provides the example from which models learn patterns and their relationship. High quality and diverse data improves how well models perform and generalize to new situations. Importance of data mining in machine learning. It helps model to understand real world scenarios and adapt to practical uses. Features extracted from data are important for effective training. Separate database for validation and testing measure how well the model works on unseen data. Data drives continuous improvement in models through feedback loops. Benefits of machine learning. Enhance efficiency and automation. That is, ML automates repetitive tasks, freeing up a human resource for more complex work. This leads to faster, smoother process and higher productivity. Another one is data-driven insight. It can analyze large amount of data to identify patterns and trends that might be missed by people and help business make a better decision. Improved personalization. It customize user experience by tailoring recommendation and ads based on individual preference. Advanced automation and robotics. It helps robots and machines to perform complex tasks with greater accuracy and adaptability. This is transforming industries like manufacturing and logistics. Applications of machine learning. Machine learning is used in many industries to solve problems and improve scenarios. Here are some common real-world applications, that is healthcare. It helps doctors to diagnose diseases from medical images like X-ray and MRI. It also predicts patient outcome and personalized treatment, which improves healthcare quality. Finance. In finance, it detects fraudulent transactions in real time and supports algorithmic trading. It also helps to access credit risk, help in making lending safer and faster. In retail and e-commerce, it helps in personalized product recommendation and forecast demand to optimize inventory and also analyze customer sentiment to improve shopping experience. And another one is the transportation and automatic. Self-driving cars rely on ML to navigate and make decisions. It optimizes delivery routes and predict vehicle maintenance needs, which reduce downtime. Another one is social media and entertainment. Platforms like Netflix and YouTube use ML to recommend content we will enjoy. They enable image and speech recognition for better user interaction. In the field of manufacturing, it improves quality control by detecting defects in product automatically and predicts machine failure in advance and helps in production process. What are the chances of machine learning? That is data bias and fairness. ML model learn from the training data, and if the data is biased, model's decision can be unfair. So it is important to select and monitor data carefully. Another one is security and privacy concern. Since it depends on large amount of data, there is a risk of sensitive information being exposed. So protecting privacy is very important. Another one is interoperability, interpretability and explainability. Complex ML models can be difficult to understand, which makes it difficult to explain why they make a certain decision. This can affect the trust and accountability. Another one is job displacement and automation. Automation may replace some jobs, so retraining and helping workers learn new skills is important to adapt to these changes. What are the types of machine learning? That is supervised learning, unsupervised learning, reinforcement learning. Let's now see about supervised learning. Training models on labeled data to predict or classify new unseen data. Likewise, unsupervised data, it finds patterns or groups in unlabeled data like clustering or dimensionality prediction. In the field of reinforcement learning, learns to trial and error to maximize rewards, ideal for decision making tasks. And now let us see about the supervised learning. Supervised learning is a type of machine learning where a model learns from labeled data and every input has a corresponding correct output. The model makes prediction and compares them with the true output, adjusting itself to reduce errors and improve accuracy over time. The goal is to make accurate prediction on new unseen data. For example, a model trained on images of handwritten digits can recognize new digits it has never seen before. Types of supervised learning. It can be classified into two types, that is classification and regression. In classification, the output is a categorical variable, that is spam with non-spam emails, yes with no likewise. In regression, the output is a continuous variable, example predicting house prices, stock price, etc. Working of supervised machine learning, that is collect labeled data, gather a data set where each input has a known correct output. Example, image of handwritten digits with their actual numbers as labels. Another one is split the data set, that is divide the data into training data and testing the data. The model will learn from the training data and will be evaluated on the testing data. Train the model. Feed the training data to a suitable supervised learning algorithm. Then the model tries to find patterns that map inputs to correct outputs. Working of supervised machine learning, that is validate and test the model. Evaluate the model using testing data it has never seen before. The model predicts output and these predictions are compared with the actual label to calculate accuracy or error. Another one is deploy and predict on new data. Once the model performs well, it can be used to predict output for completely new unseen data. Supervised machine learning algorithm. Supervised machine learning algorithm can be further divided into several different types, each with its unique characteristics and applications. Here are some of the most common types of supervised learning algorithm, that is linear regression. It is a type of supervised learning regression algorithm that is used to predict a continuous output value. It is one of the simplest and most widely used algorithm in supervised learning. Logical regression, that is, it is a type of supervised learning classification algorithm that is used to predict a binary output variable. Another one is decision tree. It is a tree-like structure that is used to model decision and their possible consequence. Each internal node in the tree represents a decision, while each leaf node represents a possible outcome. Supervised machine learning algorithm, that is a random forest. Again, it is made up of multiple decision trees that work together to make a prediction. Each tree in a forest is trained on a different subset of the input features and the data. The final prediction is made by aggregating the prediction of all the trees in the forest. Another one is the support vectoring machine, that is SVM algorithm, creates a hyperplane to segregate a dimensional space into classes and identify the correct category of new data points. The extreme case that help create the hyperplane are called support vectors, hence the name support vector machine. Another one is K nearest neighbor, that is KNN, works on finding K training examples closest to a given input and then predicts the class or value based on the majority class or average class of this neighbor. The performance of KNN can be influenced by the choice of K and the distance metric used to measure proximity. Another one is gradient boosting, that is, it combines the weak learners like decision trees to create a strong model. It iteratively builds new models that correct errors made of previous ones. Another one is Navy Bayes algorithm. It is a supervised machine learning algorithm based on applying Bayes theorem with the Navy assumption that features are independent of each other given the class label. Advantage of supervised learning, that is, it is simplicity and clarity, that is easy to understand and implement since it learns from a labeled example. Another one is high accuracy. When sufficient labeled data is available, models achieve a strong predictive performance. Versatility works for both classification like spam detection, disease prediction, and regression like price forecasting. Another one is generalization. With enough diverse data and the proper training, models can generalize well to unseen input. Wide application used in speech recognition, medical diagnosis, sentiment analysis, fraud detection, and more. What are all the disadvantages of supervised learning? It requires labeled data, that is large amount of labeled data set are expensive and the time consuming to prepare. Another one is bias from data. If training data is biased or unbalanced, the model may learn and amplify those biases. Another one is overfitting risk. Model may memorize training data instead of learning general patterns, especially with a small data set. Then limited adaptability. Performance drops significantly when applied to data distributions that are different from training data and not scalable for some problem. In such a task with millions of possible labels like natural language, supervised labeling becomes impractical. Let us see about unsupervised learning. It is a type of machine learning when the model works without labeled data. It learns patterns on its own by grouping similar data points or finding hidden structures without any human intervention. It is used for tasks like clustering, dimensionality, reduction, and association rule learning. It helps to identify hidden patterns in data. And also it is useful for grouping, compression, and anomaly detection. Working of supervised learning. Likewise, supervised learning, unsupervised learning also collect data. It collects unlabeled data. Gather a data set without predefined labels or categories. Examples, images of various animals without any tags. Select an algorithm. Choose a suitable unsupervised algorithm such as clustering like k-means, association rule learning like a priori, or dimensionality reductions like PCA based on the goal. Another one is training the model on raw data. Feed the entire unlabeled data set to the algorithm. The algorithm looks for similarity, relationship, or hidden structures within the data. Another one is group or transform data. The algorithm organizes data into groups, that is cluster, rules, or lower dimensional forms without human input. Example, it may group similar animals together or extract key patterns from large data set. Another one is interpret and use results. That is, it analyzes the discovered groups, rules, or features to gain insight or use them for further tasks like visualization, anomaly detection, or as input for other models. There are three types of unsupervised learning that are clustering. Clustering, it is an unsupervised machine learning technique that groups unlabeled data into clusters based on similarity. Its goal is to discover patterns on a relationship within the data without any prior knowledge of categories or labels. Groups the data point that share similar features or characteristics. It helps find natural grouping in raw unclassified data also. Commonly, it is used for customer segmentations, anomaly detection, and data organization. Works purely from the input data without any output labels. Enables understanding of data structure for further analysis or decision making. Another one is association rule learning from unsupervised learning. It is a rule-based technique used to discover interesting relationship between variables in large data set. It identifies patterns in the form of if-then rules, showing that how the presence of some of the items in the data implies the presence of others, and also it finds a frequent item combination and the rules connecting them. Another one is commonly used in a market basket analysis to understand the product purchase relationship, and also it helps retailers design promotion and cross-selling strategies. Another unsupervised learning algorithm is dimensionality reduction. It is the process of decreasing the number of features or variables in a data set while retaining as much of the original information as possible. This technique helps simplify complex data, making it easier to analyze and visualize. It also improves the efficiency and performance of the machine learning algorithm by reducing noise and computational cost. It reduces the data set feature space from many dimensions to fewer, more meaningful ones. It helps us focus on the most important traits or patterns in the data, commonly used to improve model speed and reduce overfitting. Application of unsupervised learning. That is, it has a diverse application across the industries and domain. They include customer segmentation, that is, algorithm cluster customers based on purchasing behavior or demographics, enabling targeted marketing strategies. Another one is anomaly detection, identifies unusual patterns in data, aiding fraud detection, cyber security, and equipment failure prevention. Another one is recommendation system. It suggests products, movies, or music by analyzing user behavior and preference. Image and text clustering. Groups similar images or documents for tasks like organization, classification, or content recommendation. Another important one is social network analysis. It detects communities or trends in user interaction on social media platform. Advantages of unsupervised learning, that is, no need for labeled data. Works with raw, unlabeled data, hence saving time and effort on data annotation. And also it is used to discover hidden patterns, finds a natural grouping and a structure that might be missed by humans. It also handles a complex and large data set for effective high dimensional or vast amount of data. It is useful for anomaly detection, can identify outliers and unusual data points without prior examples. Disadvantages of unsupervised learning, that is, it produces noisy data. Outliers and noise can distort the patterns and reduce the effectiveness of algorithm. Another one is overfitting risk. Overfitting can occur when models capture noise instead of meaningful patterns in the data. Limited guidance. The absence of labels restrict the ability to guide the algorithm toward a specific outcome. Another one is cluster interpretability. Results such as cluster may lack clear meaning or alignment with real world categories. Another one is reinforcement learning. It is a branch of machine learning that focuses on how agents can learn to make decisions through trial and error to maximize the cumulative rewards. RL allows machines to learn by interacting with an environment and receiving feedback based on their action. This feedback comes in a form of rewards or penalties. Reinforcement learning, it involves around the idea that an agent interacts with an environment to achieve a goal. The agent performs the action and receives feedback to optimize its decision making over time. The agent may be the decision maker that performs the action. Environment, the world or system in which the agent operates. Another one is state, the situation or condition the agent is currently in. Action, that is the possible moves or decision the agent can make. Reward, the feedback or result from the environment based on the agent's action. What are all the core components? That is policy. It defines the agent's behavior, that is maps state for action. Can be simple rules or complex computation. For example, an autonomous car maps pedestrian direction to make necessary steps. Another one is reward signal. It represents the goal of the RL problem, guides the agent by providing feedback. For example, for self-driving cars, rewards can be fewer collisions, shorter travel time, land discipline. Another one is value function. It evaluates long-term benefits, not just immediate rewards. Measures desirability of a state considering future outcome. For example, a vehicle may avoid reckless maneuvers to maximize overall safety and efficiency. Another one is model. It simulates the environment to predict outcome of action, enable planning and foresight. For example, predicting other vehicles' movement to plan safer routes. Then working of the reinforcement learning, the agent interacts iteratively with its environment in a feedback loop. The agent observes the current state of the environment. It chooses and performs an action based on its policy. The environment responds by transitioning to a new state and providing a reward. The agent updates its knowledge based on the reward received and the new state. This cycle repeats with the agent balancing exploration, and exploitation to maximize the cumulative reward over time. Types of reinforcement learning, that is positive reinforcement, is defined as when an event occurs due to a particular behavior, it increases the strength and the frequency of the behavior. In other words, it has a positive effect on behavior. Advantages, it maximizes performance, helps sustain change over time, and a disadvantage is overuse can lead to excess state that may reduce effectiveness. Another one is negative reinforcement, and that is, it is defined as a strengthening of behavior because a negative condition is stopped or avoided. Advantages, it increases behavior frequency, ensure a minimum performance standard, and also a disadvantage is it may only encourage just enough action to avoid a penalty. Application of reinforcement, that is robotics. RL is used to automate tasks in structured environments such as manufacturing, where robots learn to optimize movement and improve efficiency. Another one is games. Advanced RL algorithms have been used to develop strategies for complex games like chess, Go, and video games, outperforming human player in many instances. Industrial control. RL helps in a real-time adjustment on optimization of industrial operations such as refining process in the oil and the gas industry. Another one is personalized training system. RL enables the customization of instructional content based on an individual's learning patterns, improving engagement and effectiveness. Advantages continues such as it solves a complex sequential decision problem where other approaches fail. Learns from real-time interaction, enabling adaptation to changing environment, does not require labeled data, unlike a supervised learning. Can innovate by discovering new strategy beyond human intuition. It handles uncertainty and static environment effectively. Likewise, disadvantage of reinforcement is computationally intensive, requiring large amount of data and processing power. Reward function design is critical. Poor design leads to unintended behaviors, not suitable for simple problems where the traditional methods are more efficient. Challenging to debug and interpret, making it hard to explain decision. Exploration, exploitation trade-off requires careful balancing to optimize learning. Thank you.